My name is Gabriella Romano, and this is my presentation on Google's Project Soli. Wave hello to Soli. ATAP, which stands for Advanced Technologies and Projects, is a division within Google that helped create the Project Soli. What is Project Soli, you might ask? Well, in simplest terms, what it is a chip that can detect gestures with fingers and hands. This puts you in a sort of virtual world where you are pressing, dialing, or sliding the invisible object, as you can see in the image. You are clicking a button, you're dialing, and you're sliding. These are the interactions that the project is trying to create and imagine. These interactions make it feel real. Although these controls are just virtual, the interactions you are creating for it, such as using it as a button, dialing, or sliding, makes it feel very much real. What can I use this for, you may ask? Well, you can use it for playing games on mobile devices, computers, and electronics. They have pushed the processing power of electronics to do the sensing part for us now. There are many things recently that Project Soli has done, such as object recognition. Soli can actually be used to recognize particular objects. It has so far been used to recognize air, water, milk, aluminum, copper, and steel. Other recent things this project has done was 3D imaging, predictive drawing, in-car remote, security, and visualization. These things continue to advance. Attached, you will see an image which shows how the object is recognized, and then it shows what object it recognized. So in the picture example, it shows that it predicts plastic. They put the plastic on top of the chip and it recognizes it. Attached is another image to show how the Project Soli will work in an in-car remote. Basically, what happens is the person lifts their hand to show a phone motion and it answers the phone for them. You may ask how it works. It works by emitting electromagnetic waves into a broad beam. Now, a more in-depth explanation can be shown on Soli's website. Overall, they say there is an object within the beam that scatters this energy, reflecting it back towards the radar antenna. Properties of the reflected signal, such as energy, time delay, and frequency shift, capture rich information about the object's characteristics and dynamics, including size, shape, orientation, material, distance, and velocity. It recognizes gestures expressed with the motion of your fingers and your hand. Like showed in the picture earlier, attached you will see an image which is a great visual explanation to show you the wavelength in which this works. This energy from your hand gesture is being pushed back to the radar antenna. This energy is then captured and used to recognize your expression. The sensor tracks sub-millimeter motion at high speeds, recognizing your hand gestures. So you can see in the photo, it's pushing it and it's receiving it. Now, you may ask, how is this different from other radar sensors? It does not require large bandwidth and high spatial resolution. So Soli's spatial resolution is actually coarser than the scale of most finer gestures. It relies on motion resolution by extracting subtle changes in the received signal over time. With this, Soli can distinguish complex finger movements and deforming hand shapes within its field. Other examples of how it's different from other radar sensors is it can work through materials and you can embed it into objects as well. Radio frequency. Now, to explain radio frequency a bit more in depth, it is technology which transmits a radio wave toward a target and then the receiver of the radar intercepts the reflected energy from that target. The full gesture recognition pipeline within this chip helps to recognize those hand gestures that you have made. So they use gesture recognition pipeline and specific hand gestures. You have to use specific hand gestures for the chip to be able to understand, like discussed earlier in the photo I showed. Now attached is actually an image of the Soli hardware prototype from July 2014 to May 2015. Now there were two architectures developed in making Soli. One was a frequency modulated continuous wave radar, and another was a direct sequence spread spectrum radar. Both of these chips integrate the entire system into the package, including multiple beamforming antennas that enable 3D tracking and imaging with no moving parts. Attached, you will see an image of the actual chip, Soli, which will be placed into computers, phones, cars, and other day-to-day devices within the environment. The chip is approximately 8 by 10 millimeters. The project wishes to create gesture interaction language that will allow people to control devices with a simple universal gesture. Here is a visual representation of the chip compared to a quarter. As you can see, it's extremely small compared to it. Another example is a smartwatch. They used this in the beginning to test it mainly. They had said if you could put something into a smartwatch, you could put it anywhere. Their first Soli prototypes were an LG watch Urbane and a JBL speaker. Now, their main goal overall is to get this on the store shelves. ATAP has been doing a partnership with LG, Qualcomm, and JBL to be making this happen. Now, if you want updates, you can actually sign up on Soli, which is at atap.google.com/Soli. Not only can you choose to be updated, but you can actually choose to select an option as developer, researcher, or press. Project Soli is actually looking for help. They are seeking for people to help evolve, test, and build this technology.